Okay, and in this section, I kind of combined two sections and took important things from both. So we'll do it in one lesson. So, but it's kind of a lot. So let's get started. Angles. An initial side of an angle is the fixed ray. The terminal side is a ray of an angle that rotates about the center. So let me show you what that looks like. If you have axes, we'll do two different sets of axes. The initial side we'll put on the x-axis. This is going to be in standard position, which we always use standard position basically. The initial side, initial means the starting side, initial side. The terminal side is once you rotate around the center, 0, 0 is the vertex is, you can rotate a bunch of different ways. You could put an angle like this. You can have an angle that looks like this, angle down here. You can do a bunch of different angles. Now this, first we'll do positive angle measures. Positive angle measures are ones that are counterclockwise, or CCW. Counterclockwise means the way the opposite the way the clock goes. So the clock goes this way. That would be clockwise. Counterclockwise would be the other way, like that. That would be counterclockwise. So positive angle measures go counterclockwise. So the way we show that is just to draw an arrow. So this arrow is going counterclockwise. So that's positive angle measure. This angle is going counterclockwise. So this is positive angle measure. A negative angle measure. Negative angle measure would be clockwise. So here are two examples. Negative angle is clockwise. So we could have an angle that looks like this. Kind of like the first one that we just did. What makes this negative, at this point we can't really tell if it's positive or negative. You have to show the rotation, that you rotate this way, and that is a negative angle measure. For this other one, you could have a different angle measure. Say we're down here. This angle clockwise, this would be a negative angle. So that's the difference between positive and negative angles. An angle whose terminal side has made one revolution measures 360 degrees. So a full circle is 360. Half of a circle is 180. And half of 180 is 90, etc. So draw an angle. Part of the homework's pretty easy. You get to just draw angles. Okay, so draw an angle of 240. This is 0 degrees. Here's 90 degrees, 180 degrees, and 270 degrees, and then 0 is also 360 degrees. So 240 would be in the third quadrant. Here's the initial side, and somewhere down here. And this would be 240 degrees. 300-degree angle. Initial side is on the x-axis. And 300 degrees maybe is in the fourth quadrant, somewhere down there. And this rotation is 300 degrees. And negative 150. Negative 150 is going to be clockwise. So if you're going clockwise, down here is negative 90, negative 180, negative 270 at the top. So that would be in this quadrant. And we show it's negative by doing clockwise. So that would be a negative angle. A negative 400. Normally you might think, well, 360 is one time around the circle. 400 is a little bit more than that. So you would have the initial side. You go around the circle once, clockwise, and a little bit more. We would put negative 400 degrees down here in the fourth quadrant. Just to remind you, quadrants. First, second, third, the fourth quadrant. So negative 400 is in the fourth quadrant. So that's drawing angles. We'll do more drawing angles later in class. So hopefully that's not too difficult for you. Next, I want to explain a little bit about what we were saying yesterday about radian mode. You should leave your calculator in degree mode, and it should be in degree mode now. But radian mode is another way of measuring angles. So if we have a circle, insert a circle here. Oh, I just use that one, I guess. Okay, so if we have a circle, and, oh, I should put it right here. If we have a circle, there we go, there's a circle. If we have a circle with a radius of 1, so here's axes, this radius is 1. There's two different ways to measure angles. One way is to measure the angle with how much it opens, like this. The other way to measure an angle is this length of the arc. So if you use how much does the angle open, like this, that's talking in terms of degrees. If you're talking about the length of this arc, that's radians. So that's the difference, the essential difference between degrees, how much an angle opens like this, and then radians is the length on the circle, the length of the arc. So a radian is the measure of an angle whose rays intercept an arc of length 1 unit on the unit circle. So if you think about going all the way around the circle, that would be 360 degrees, is 1 revolution. And if we went 1 revolution on the circumference of a circle is 2 pi r, and in this case the radius is 1. So the circumference, the distance around the circle, the perimeter, the circumference, is 2 pi. So 2 pi would be 1 revolution. So we could say 360 degrees equals 2 pi radians, the transitive property. They both equal 1 revolution. So 360 degrees is 2 pi. We can divide both sides by 2. So 180 degrees equals pi radians. And that leads us to a conversion, how we can convert from degrees to radians and radians to degrees. With these right here, if you're converting from degrees to radians, you multiply by pi over 180. If it's radians to degrees, you multiply by 180 over pi. And I'd like you to memorize those so you know how to go back and forth. And this is really the main thing we'll do with radians. We don't do too much else than converting back and forth. In other classes, you'll do more with radians. So here are some examples you could see. Convert from degrees to radians. So the way that I remember it, to figure out which one goes on top, 180 or pi, if I'm given degrees, this is 60 degrees, 180 has a degree mark with it, so I want to cancel and divide out the degrees. So I would be left with pi radians in the numerator. So this would be 60 pi over 180, which would simplify to be pi over 3. So 60 degrees is the same as pi over 3 radians. Then you could do the same thing on the next one. You'd multiply by pi over 180. If you need to, you can use your calculator. They're both divisible by 45, so you could divide 45. But if you didn't know that, you'd have negative 225 divided by 180. And that would give you a fraction. So you could write your answer as negative 1.25 pi. If you actually divide it by 45, you get negative 5 pi over 4. So either answer is appropriate for this. Then we can go the other way. To convert from radians to degrees, we multiply. The 180 is in top now, over pi. And in this case, the pi's divide out. 180 divided by 4 is 45. So you would get 495 degrees. You would get that if you use your calculator. 11 times 180 divided by 4 is 495. 5 pi over 4, I'm going to rewrite this because I don't like how I wrote it. 5 pi over 4, you multiply by 180 over pi. And when you simplify that, you get 225 degrees. And make sure that you include the degree mark when your answers are in degrees. When your answers are in radians, you don't write any degree mark. You don't have to write the word radians. Just leave it like that. Okay, the next part we'll do some drawing again, which is fun. A reference angle. A reference angle is an acute angle. Acute is less than 90 degrees. The terminal side of theta and the x-axis. It's important that you know it's the x-axis. So what that means is a reference angle. We sketch the angle of 240, which is in the 4th quadrant. And now we draw. We have to figure out what angle we're talking about. So the angle, we're going to draw a vertical line that's perpendicular to the x-axis. Like I said, it has to be the x-axis. You don't want to draw this line that's perpendicular to the y-axis. That would be incorrect. It's going to mess you all up. You want a vertical line, this vertical line. So that is, the line that you draw is always vertical. It is always in relation to the x-axis, perpendicular to the x-axis. So it's always vertical. Okay, so here's your angle. This is your angle of 240. You need to find theta. That's your reference angle. We're going to use that to evaluate trig functions soon in the class notes right below this. So if this is 180 and this is 240, between 180 and 240 is 60 degrees. So your reference angle theta is 60 degrees. So see if you could draw this 150 and find the reference angle. On the next two, we can convert 4 pi over 3 to degrees. So that would be 180 over pi. Converting that, you'd get 240 degrees, which we actually just did on the first one. So I'm not going to do that again. It would look like this, and it'd be a 60. We already did that. This one we'd multiply by 180 over pi. The pi's cancel. You get 150 degrees. And that one we actually did it right over here. So you get a 30 reference angle. So I accidentally gave you the same degree measurements on this. But we're going to use reference angles, what we just did, reference angles. We're going to use them to evaluate trig functions without a calculator. So we can do this without a calculator. Finding the trig value of any angle is the same as finding the trig value of the reference angle. So your homework's going to have a bunch of these questions, and it's not going to give you axes. So I do not want you to do your homework just by doing this. Cosine of 120. That's the answer, negative 0.5. I want you to show work so I can see you know why that is what it is. Why does cosine 120 equal negative 1/2? The way we do that without a calculator, the way we do that is graph the angle 120, like so. Draw your angle, theta is closest to the origin. It's always the one close to the origin. And it's always a vertical line that you draw, perpendicular to the x-axis. And if this is 120, our reference angle theta, here's 180. We got 120. How much more do we need right here to get to 180? That would be 60. And notice we have a 30, 60, 90 triangle. And I should review a little bit at least, just to make sure you remember. 30, 60, 90 triangle. We'll make this 60. Here's 30. What are the sides of a 30, 60, 90 triangle? We're going to use these numbers. So you need to make sure you know these numbers, and then you need to make sure you know the 45, 45, 90 triangle. 1, 1, square root 2. Okay, so going back here. 60 was our reference angle. Across from 60 is square root 3. Square root 3. Across from 30 is a 1. Now here's a tricky part. since this side of the triangle is on the left of the origin, this 1 is a negative 1. This side, square root 3, is above the origin. Above is positive, so that's okay. And then the hypotenuse is 2. So cosine of 120 is the same as cosine of this 60, which is adjacent over hypotenuse. So the answer is -1/2, and that's why the calculator is right, -1/2. And we just showed that the calculator is correct. Okay, sine of 330 degrees. Sine of 330 is in the 4th quadrant. Vertical line that's perpendicular to the x-axis. So this angle is 330. The whole thing is 360. So that means you would have a reference angle in here of 30 degrees. And down here you'd have a 60. So we have 30, 60, 90 again. Across from 30 is a 1. However, since you're going down below the origin, below the axis, this would be a negative. 60 would be square root 3 and a 2. So this would be -1/2. Opposite over hypotenuse. Tangent of 225. See if you could draw a tangent of 225, determine the reference angle, and fill in the blanks. So you'd have third quadrant. The whole thing's 225 minus 180 would be 45 degrees. You'd have 1, -1, square root 2, and both actually are negative. So you would have -1 over -1, opposite over adjacent. So your answer is +1. Okay, on the next two, I'd like you to try sine of 300. You're going to be in the 4th quadrant. Fill in the blanks of the triangle and evaluate sine 300. And then cosine 315, you're going to be in the 4th quadrant again. So this angle is 315, and this angle is 300. Okay, on the next one, we have a problem. The method I just showed you doesn't work, because if you graph your angle, here's your angle, you have to make a line vertical to make a triangle. You don't have a triangle, so you can't use this method. You have to use a different method, which I'm going to show you on the next page. We'll do these later. On this page, this is how you deal with something that's called a quadrantal angle. It sounds like quadrant. Quadrantal angle is an angle whose terminal side lands on an axis. So you have 4 main quadrantal angles. You have, or 5 I guess. You have 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and then I guess the 5th one would be 360 degrees. Those are the main ones, those 5. So what do you do if you're asked to evaluate, like this, sine of 270 degrees? You can't use the method I just showed you. Well, you need to know 2 things. One thing is this is a unit circle, so the radius is 1. So the coordinates of this point would be 1, 0, 1 over in the x, 0 on the y. The coordinates of this point would be 0, 1. Coordinates of this point would be -1, 0, and the coordinates of this point would be 0, -1. So you need to know these ordered pairs, these points. You also need to know that x corresponds to cosine and y corresponds to sine. Why is that? Well, if you had a circle, these are the axes, x and y axis. We have a point right here that's x, y. If you drew a triangle, and that's my theta, notice your x coordinate is this length, which if you did, this is radius of 1, if you did cosine of theta, cosine of theta would be x over 1. So cosine theta equals x over 1. So cosine is the same as the x coordinate on the unit circle. If you did this side, opposite over hypotenuse, that would be sine theta equals y over 1. So sine corresponds to the y coordinate. And similarly, y over x is tangent. So if you're asked to evaluate sine of 270, you can say, well, here's my angle of 270. I'm at this point. The coordinates of that point are 0, -1. And sine corresponds to the y coordinate. So sine of 270 degrees would equal -1. And just to verify, sine of 270 equals -1 using the unit circle. If we did tangent of 90 degrees is this angle. The coordinates of this point would be 0, 1, and tangent corresponds to y over x. Y divided by x, the y coordinate is 1, x coordinate is 0, 1 divided by 0 is undefined. To verify that, in case you don't trust me, tangent of 90 is domain error. It's undefined. Tangent of 90. Secant of 360, we go around the circle once. We're back to this point. The ordered pair is 1, 0. And secant is the reciprocal of what function? Secant is the reciprocal of cosine. Cosine corresponds to the x coordinate. So cosine of 360 is 1, and the reciprocal of 1 is 1. So the answer would be 1. Um, 3 pi over 2. 3 pi over 2 is the same as 270, which would be this. So sine of 3 pi over 2 is the y coordinate, -1. I'd like you, in our last minutes, I'd like you to do sine of pi. If you need to convert it to degrees, go ahead. Sine of pi, cosine of pi over 2, and then one of these at the top. So you might have to convert to degrees. Well, you probably will have to convert to degrees. So your choice. One of these top three. I want you to do those bottom two, and then I'll show you the answers soon.